For the last 20 years, we've been living in a period of solar calm, a quiet phase that allowed us to build a global infrastructure entirely dependent on satellites and delicate orbital hardware. But that phase just ended. In recent years, especially 2026, the Sun entered its most violent active period in 2 decades, and the data coming back from our deep space observatories is starting to look less like a predictable cycle and more like a systematic threat. We aren't just talking about pretty auroras anymore. We're talking about X-class flares so massive they are physically compressing the boundaries of the heliosphere and warping the magnetic shields of every planet in the system. This is a forensic look at a level of stellar aggression that we haven't seen in the modern era. When we look at the surface of the Sun right now, we're seeing the results of a massive magnetic knot that has been tightening for over a decade. This is a mechanical process called differential rotation, where the Sun's equator spins faster than its poles, physically stretching the internal magnetic field lines until they snap. By early 2026, this tension reached a breaking point, resulting in a series of X-class eruptions that were effectively structural failures of the solar atmosphere. We've recorded single events that launched over 1 billion tons of plasma into the vacuum at speeds exceeding 4 million miles per hour. It creates what we call a halo CME, a shockwave of charged particles that expands to fill the entire inner solar system, physically sandblasting the magnetic envelopes of Earth and every planet it touches. The data from these recent events show that the Sun's magnetic poles are in the middle of a flip that occurs every 11 years, but is currently happening with an intensity we haven't seen in this generation. We are watching the primary engine of our system purge its internal pressure, and for the first time in many years, we have the forensic tools to see exactly how violent that process is. The reason these eruptions are so violent comes down to a process called magnetic reconnection, which is essentially the solar version of a structural snap. As those magnetic field lines get twisted and forced together by the Sun's internal churn, they eventually reach a point where the physics simply breaks, meaning they cross and reconfigure in a fraction of a second. That sudden snap releases a burst of kinetic energy that is almost impossible to wrap your head around. And you have to realize, this isn't just a flash of light. It's a massive, invisible slingshot that launches billions of tons of ionized gas into the vacuum. That creates a shock wave traveling faster than almost anything else in the system. Because the Sun is currently in such a chaotic state, these snaps are happening in rapid succession. So when these particles hit a planet, they physically compress the target's magnetic shield, which is why it's a direct transfer of power from the solar core to the planetary shells. This proves that the Sun is a physical actor that can reshape the geology of every world it touches. We're pretty much looking at a star that is effectively sandblasting its own family of planets. And while this sounds like a distant cosmic event, the reality is that Earth is currently acting as the primary target for this solar output. See, our planet is encased in a massive magnetic envelope called the magnetosphere, which acts as a structural buffer against the solar wind. But even this shield has its limits, and when a billion-ton shockwave of plasma hits that boundary, it compresses the entire magnetic field. Essentially, this compression creates a massive electrical feedback loop. As the magnetic field lines are pushed and pulled by the solar gusts, they generate trillions of watts of current that flow directly into our upper atmosphere, which is why we're seeing auroras appearing much closer to the equator than they ever should. But beyond the light show, this energy transfer is physically causing our atmosphere to expand outward into the path of low-orbiting satellites. So the problem is the fact that the Sun is literally changing the shape and density of our planet's outer layers. It's a reminder that we are living inside the atmosphere of a star, and as it redlines, the boundary between space and Earth begins to blur. And while Earth has its magnetic buffer to soften the blow, worlds like the Moon and Mars are taking the full force of this solar peak. Without a global magnetic field, the lunar surface is effectively being bombarded by a high-velocity stream of protons that physically kick atoms off the regolith. Essentially, the Sun is sputtering the lunar crust that creates an ultra-thin atmosphere of metallic vapor. But the situation on Mars is even more violent. Because its atmosphere is already so thin, these X-class shock waves are reaching all the way down to the surface. which means the red planet is being physically scoured by the solar wind. The atmospheric erosion on Mars is the direct result of a radiation environment that has officially surpassed every benchmark of the last 2 decades. In January, for instance, deep space observatories recorded a severe S4 solar radiation storm, a level of particle intensity that hasn't been observed since the infamous Halloween storms of 2003. The record-breaking streak escalated in early February with the eruption of a massive X8.3 solar flare. Launched from a sunspot region the size of multiple Earths, this event released a shockwave of extreme ultraviolet radiation that ionized the upper layers of every atmosphere in its path. This velocity is critical. At these speeds, the plasma functions as a kinetic hammer, delivering a mechanical blow to the magnetic envelopes of the planets that we are only now beginning to quantify. The frequency and raw power of these 2026 events confirm that the quiet phase we relied on to build our spacefaring infrastructure was a statistical fluke. We have returned to a high-energy baseline where the Sun is capable of launching billion-ton projectiles in rapid succession. These record-breaking events of February were likely not the final peak of this cycle. Solar Cycle 25 is now trending toward a double peak maximum, a phenomenon where the Sun's magnetic activity surges in 2 distinct waves over an 18-month window. This means the extreme radiation flux we recorded in early 2026 is likely to be matched or surpassed. Historically, the most violent geomagnetic storms, like the Carrington event or the 2003 Halloween flares, actually occur during the period immediately following the sunspot peak. As the large active regions migrate toward the solar equator, they become more likely to launch Earth-directed CMEs. It's important to clarify that this solar peak is not a direct physical threat to life on the surface. Earth's density and magnetic field act as a multi-layered shield that absorbs 99% of the incoming radiation. But it does put the massive influx of low-orbit satellites and the Artemis II crew missions into a high-risk operational environment. The question now is whether our modern infrastructure can actually withstand a full return to this baseline, or if we are simply waiting for the one event that finally breaks the grid. I guess we'll have to find out once it hits.